Okay, so what we're working on in this lesson is special products of binomials. Last lesson we learned how to do the distributive property method, and then we also learned the box method. Those methods will work for these problems, but when we get to the next chapter and later on when we have to start factoring things, which is working backwards, it's extremely helpful if you recognize these patterns that we're going to show you right here. Okay, so when you have the square of a binomial, what that means is it's the same thing twice. We'll look at that highlighting. And there's two options. There's the sum, and then there's difference. It's the same rule. Only thing that's going to be different is the sign. So when I do this, let's visually see what happens. I get an a plus b and an a plus b. And so when I distribute, it's a squared plus ab, and then I do this next one. That's an ab. Even though it's backwards, it's still ab, and then b squared. So this first thing makes sense, and this is what most people are going to do. Most people are going to do this, and they're just going to say, oh, it's a squared plus b squared. Well, that would leave off this whole middle part, and that's where the trick is. I know I have to multiply those together, and a times b is ab, but I'm doing that twice. So the rule is you double the two middle terms. So whatever a times b is, you times it by 2. And because this was a plus, this becomes a plus. So let's do an example with maybe some numbers. So let's say I have x plus 7 squared. So I'm going to have x squared, and I'm going to have 7 squared, which is 49. But remember what happens if you wrote it out twice. You're going to have this thing right here, 7x, but then you're also going to have it on the last one, another 7x. So what we do is we multiply these two numbers, 7 times x, and then you double them because you're going to have that twice. So 7 times x is 7x, times 2 is 14x. So let's try it on this one, doing the same rule, but without showing these extra steps. So I know I'm going to have to square the a, so it's a squared. I'm going to have to square the b, so it's b squared. Now here's a trick. A negative b times a negative b is a positive b. This is always positive. But now I'm going to multiply a and b, and then I'm going to double it. So I get 2ab. Well, because this was both minuses, it's a negative 2ab. All right, let's use that rule underneath for one more. Let's try one over here. So let's do x minus 3 squared. So I know I'm going to have an x squared. I know I'm going to have a positive 9 because negative 3 times negative 3 is positive 9. Now what I need to do is I need to multiply these two. So negative 3 times x is a negative 3x. Well, and then I double it. And 3x times 2 is a negative 6x. And so that's how you do that problem. All right, before we go on to difference of the squares, I would like you to try 1, 2, and 3. And when you think you have it, go ahead and press play, and I'll help you check your work. All right, so the first part's pretty easy, x squared plus 25. It's the middle term that's going to get us stuck. And so 5 times x is 5x, but you're going to have 2 of them, so it's a positive 10x. There you go. All right, here's the next one, x squared. And remember, it's always a plus at the end because a negative times a negative is a positive. And again, I have to look at these. Negative 4 times x is negative 4x. But then you have to double it. And so that gives me negative 8x. Just make sure it looks like a double, not a squared. All right, here. Now you have to be careful on this one. Did you do 2x squared or did you do 2x times 2x and realize that you have to square the 2 also. So it's actually 4x squared. And then we have a plus 9 because 3 times 3 is 9. Now, when I look at my middle terms, that is 6x. But remember, we have to double it, so it's actually a 12x in the center. Okay. And again, these rules are nice if you memorize them, if you get familiar with them. If you don't and you struggle with it, just use your box method or your distributive property method. All right, let's go back up now and let's learn the last rule. This last rule is called difference of squares, and this is the one that you'll see the most. So let's see what happens when we do it with a and b. So I'm going to distribute. I get a squared minus ab plus ab minus b squared, because I only have one negative there. Well, look what happens. I have a positive ab and a negative ab, so those cross off. So I get a squared minus b squared. This is why it's called a difference of squares, because I have a squared and I'm minusing another square, which was b squared. So what happens is the middle term always is going to cross off because I have a positive one and I have a negative one. And so if you notice here, it has to be an x plus 3 and an x minus 3. So it's the exact same thing in both parentheses, but one has a positive and one has a negative. All right, so now I know that this is going to be x squared. This is going to give me positive 3x. This one's going to give me negative 3x. And those are going to disappear. So now I just have 3 times 3, which is 9. All right, same thing here. You notice this one's 2x minus 5, and this one's 2x plus 5. So I have to square the first things. 2x times 2x is 4x squared. Now let's visualize this one more time. Negative 5 times 2x is negative 10x. And 2x times 5 is 10x. So again, those cross off. All I'm left with is this last term, which is 5 times 5, which is 25. So that's what a difference of squares does. It gets rid of the middle of term. So now what I want you to do is I would like you to try, there's none there. Oh, I don't have any examples of that. So I'm going to make one for you to try. Okay, so I'd like you to try, let's do x plus 7, x minus 7. So you try that there. And I'll give you another one underneath. Then let's do 3x plus 5. No, not 5. We just did a 5. 3x plus 2. 3x minus 2. So why don't you try those two, and then we'll see how you did. Press play when you got it. Okay, so you should have did x times x, which is x squared. Remember, the middle terms are going to cross off because I'll have a positive one and a negative one. So it's just x squared minus 49. All right, and then down here, 3x times 3x is 9x squared. Again, the middle terms are going to cross off because I'll have a positive 6x and a negative 6x. And so then 2 times 2 is 4. Okay, all right, so now I guess we got to go back and finish examples 4 and 5. Why don't you go ahead and try them? I thought they were going to be the other type. I didn't look at the notes ahead of time. So why don't you go ahead and try them and press play when you think you got it. All right, so you should have gotten 9x squared plus 16. And remember, we do 3x times 4, which is a negative 12x. But I need to double that, so it's negative 24x. All right, here, that's going to give me 9x squared and a plus 4y squared. Because remember, you have to square the number and the variable. And then when I multiply those together, I get a 6xy. But then I have to double it, so it's a 12xy. Okay? So for this section, we were just kind of learning some shortcuts and tricks that will help us in the future. If you really are not understanding it again, you could just keep doing the box method or keep doing distributive property method, and it'll work for you. But this method will save you time if you learn it.